Hi there, my name is Yury. I'm co-founder and CEO of EdgeDB. Please welcome to our short mini conference. We're live now and we will have live demos. So some funny and maybe not so funny hiccups can happen, beware. While watching this stream, please feel free to hang out on our Discord. Instructions are in the description. All right, so today we'll talk about EdgeDB, the 2.0 release and its new features, and also about our plans for the near future. I'm so excited to see you all. This is our second launch party. Approximately 6 months ago, we launched EdgeDB 1.0, and I will forever remember the day. It was a culmination of a multi-year effort to design, polish, and test our database. It was a lot of work. We often felt like we were not just reinventing the wheel, but also the roads, the electrical grid, and a bunch of other stuff on top of that. We just wanted to make sure that our data model is sound, that our query language is great, that our client APIs make sense, that it really takes 1 minute to install EdgeDB and start using it. We wanted to be sure we can commit to the design to maintain backwards compatibility. After so many years of running the company in stealth mode, we were finally ready to show it to the world. And boy, was that stressful. Things, however, played out very well. Our 1.0 launch event was watched by over 5,000 people. We climbed to the top of Hacker News and stayed there for a day. Thousands of people started EdgeDB on GitHub. Our Discord community grew from 0 to 200 people in 1 hour. And the reception was, well, it was almost too good to be true. I honestly don't remember a single negative comment anywhere. Instead, many shared their positive experience of using early EdgeDB betas and release candidates to build apps. People said that they liked SQL and would never want to write a single line of SQL again, or that they love our schema, or that they're surprised by great performance. It was such a great relief. Blessed with this early success and community love, we pretty much immediately started to work on EdgeDB 2.0. We were eager to address the early feedback that started to pour in, and we had some great ideas where the 2.0 had to land. 6 months later, we are ready to present you EdgeDB 2.0. This time it feels very different though. Our Discord community is 750 people big now, and it's growing. And you know, it's a great community to be part of. It's active, it's helping, it's positive. We have thousands of weekly active users. We have a multitude of reports of people building real production systems with EdgeDB. We see teams switching to use EdgeDB from established database products because they find it more powerful or faster or both. We now have real feedback from you, and that gives us thrills. It motivates us to do a better job and solve many of the hard problems we face. This is the time when I want to thank everybody in our community. Thank you for putting trust in us, in our product. Thank you for bug reports, for feature ideas, for your positive and sometimes not so much positive feedback. It means the world to us and makes us happy. With all that said, what's new in EdgeDB 2.0? The answer is a lot. First of all, we have a new beautiful built-in graphical user interface. Now, as soon as you create a simple schema, you can navigate through it, prototype SQL queries, do data entry, and so much more. In many cases, you wouldn't even need to build an admin panel to kickstart your project. Just start writing code. In a couple of minutes, our head of DevRel, Colin, will tell you more about it. Then we added a new powerful statement to SQL, group by. It allows you to efficiently partition and aggregate your data. It is miles better than its SQL counterpart. It's composable, powerful, and takes almost no time to master. Sully, our head compiler engineer, will tell you more about it later today. Next, we implemented object-level security and global variables. EdgeDB's data model and schema are already incredibly powerful, and you can design an optimal schema for pretty much anything. Now, you can push part of your access and business logic right into your schema. Access policies are fully programmable via global variables and the power of EdgeQL. This is one of those features that really demonstrates the power of EdgeDB. We can implement this amazing capability with great developer experience because we control all moving parts. Elvis, my co-founder and our CTO, will tell you more soon. Then, one of my favorite improvements. We optimized local EdgeDB development experience. We implemented socket activation. So now EdgeDB only starts when you want to interact with it. It automatically stops when you stop using it. You can have hundreds of EdgeDB projects on your machine, and it won't even break a sweat. While there, we also optimized memory and CPU utilization, and now we also have native ARM and M1 builds. Another new thing, our binary protocol, one of our secret weapons, graduated to version 1.0. We optimized and redesigned multiple aspects of it. We made it smarter, we made it faster, and we made it stateless. It can now be tunneled through HTTP, which opens future potential to interact with EdgeDB directly from your front-end code. The list of new features continues, and given that we're building a whole new ecosystem, this release isn't just about EdgeDB itself. It's also about updates to our CLI, our client libraries, our documentation. If you're curious to see them all, please check out the changelog and read the 2.0 announcement blog post. Feel free to also share a link to the blog post in social media. We will really appreciate that. Now it's time for me to pass the mic to Colin. He'll show you a cool demo of the new UI. Go ahead, Colin.
Awesome. Hey, everyone. Oopsie daisy. I'm going to quickly share screen here. All right, let's go. Oops. They don't make this terribly easy. All right. So just as a quick reminder, or not a reminder, our EdgeDB 2.0 launch blog post is up as well. So if you wanted to have see some of what we're going to be talking about here in written form, then you can check out that launch blog post. So we're going to be quickly running through the features of EdgeDB UI. This is something that we've been incubating for a long time internally, and we are extremely excited to share it with you guys finally. It's taken a lot of different forms and existed in sort of bits and pieces in different repos for a couple of years now, and it's finally coalesced into something that we're really, really proud to show off. So I'm just going to start off by creating a new project from scratch here. I am, just like in the V1 launch, idiotically trying to do a live demo. So, that's the kind of person I am, apparently. Going to go ahead and jump into this new launch directory I created. And then if you're following along, which you're very welcome to do, go ahead and make sure that you have the latest version of the CLI. Indeed, I've got the new Mac build, so there you have it. But I do have the latest version of the CLI here. I'm going to go ahead and just run EdgeDB project init. That's all you need to do. This will spin up a new project. And of course, every new project is associated with a brand new instance. In this case, running the latest stable version, which is 2.0. I got to tell you, it feels really good to see that. While this spins up, just as a bit of a overview of what we're going to try to do, of how this works here, is when you have a local instance, such as the one that's now linked to this project, all you have to do to open up the admin dashboard, the EdgeDB UI dashboard, is just from inside of your terminal, run EdgeDB UI. This is a new top level CLI command. And you can see this generates a JWT for us that then pops us into a localhost window, and then we actually the EdgeDB UI is baked directly into these 2.0 instances. It's able to pull that JWT and then initialize this authenticated connection to your instance. Now, I'm going to hit this EdgeDB database, which is the default database that's built into every instance. Because this database has no schema or data or anything like that at the moment, it gives us a nice prompt here. It assumes that we're going to want to jump in and start playing with the UI. And so if you're following along, then just do what I do, hit create example database. This is going to pull in our MCU sandbox schema, which you may be familiar with if you've looked at some of our examples. Basic idea. Well, I'll show you right now by jumping into the schema here. But this is the kind of top level dashboard. You can see that we have kind of three main pillars of functionality, which we're going to go through here right now. And it also gives us just a very broad strokes overview of the number of object types in our database, and then the number of actual objects that are currently stored within it. We're going to jump into the schema here. And like I said, this may look familiar if you've seen our MCU sandbox. Basic idea is kind of like a IMDb style schema for representing movies, TV shows, and then the actors that are inside of those. Let's focus in on the graph portion here. And something else I want to mention up top is we, of course, have this dark mode, though I'm going to go ahead and switch to light mode because I think it comes off a little nicer on the stream. So looking here, you can see we've got both a text-based representation of our schema and a graphical one. This looks a lot like our ESDL file, so it'll look familiar. For the moment, though, while we're just quickly scanning through the schema, we're going to stay with the graphical one. The main things to note here are that we have this abstract type called content. You can tell it's abstract because it has this gray header at the top, and then it's extended. These gray arrows here indicate inheritance. So the movie type and the show type both extend content. That's where they get that title property and the actors link. From here, if we click on a particular object type, we've got these pink arrows that show up, which are their outgoing links. So in this scenario, we have an outgoing link from show that points to person. That is the actor's link. And we can see that there's also a link property on there called character name. So let's switch back to the text-based view. Like I said, this is all fully introspected from the actively running database, and we can get text representations of all of our user-defined object types here. Search works like a charm if you wanted to find a schema, or rather an object type in a complex schema. Something else that's nifty is because we are introspecting the database, we're not limited to just seeing the types that you've defined. If you wanted to dive deep into EdgeDB and understand kind of the full inner workings of it, we can switch over to the standard lib tab here. And this is now introspecting the schema, the built-in schema, which includes all of the built-in types of EdgeDB and all of the built-in operators and functions. So for instance, if we just wanted to quickly search for a function that does some sort of regex logic, we can search re underscore, and then we can just quickly scan through all of the regex string functions that are available. That's the gist of the schema. Let's jump over to the REPL now and start running some queries here. So this is our MCU database. So when we select movie, we're going to see that that query kind of gets popped over into this notebook style format, which is going to look very familiar if you've used the CLI-based REPL. So the results of this query are printed out in our kind of annotated REPL format here that indicates what the actual type is of each object. This is particularly useful because EdgeDB supports polymorphic queries. So we mentioned that abstract type called content earlier. That's extended by both show and movie. When we execute select content, we can see that we've got some movies here that are fetched. And then further down the list, we have our lone show, which is Star Trek, not actually an MCU property, but that'll do. Now let's get a little more creative. Another important point here is if we wanted to iterate on a query and are trying out different variants of it, we can just hit this edit button, and that'll repopulate that query over on the left. And if you get tired of hitting that edit button, go ahead and hit persist query down here. And then when we execute another query here, you can see that we can now fetch the actors, and then this query stays over here on the left. And it gives you just this really fast feedback cycle when you're iterating on a complex query. So just as a bit of a sneak peek for some of the stuff that Sully is going to talk about, we can do things like play around with the new group statement, which if you wanted to play along during Sully's or Elvis's talks that are coming up about access policies or group, then spin up the EdgeDB UI, use the example database, and you can kind of experiment with things as we go along. So we can group movie by release year, for instance, and then see all of the movies that are released in any particular year. Relating to the topic that Elvis is going to go deeper on, which is access policies. I'm not going to spoil anything here, but access policies, this is a super useful time to start experimenting with how access policies work and getting a grasp of which objects are going to be available to particular queries in the context of which global variables are defined. That's just a bit of a sneak preview for what Elvis is going to talk about. Now let's go to that third kind of major pillar of functionality here, which is the data viewer. And this is where I think we've got something that pulls ahead of every other kind of admin dashboard you've probably played with before. For starters, top left corner here, we can just we can select whichever object type we care to be looking at. So as before, we can look at content, and we end up looking at both all the movies and TV shows in our database, or we can switch over to movie, for instance, and see everything in this tabular view. Something that is very cool and very EdgeQL-y is that you can start from a particular item here and just kind of dive down deep into your database really painlessly. This is kind of the visual equivalent of how easy it is to do nested fetching with shapes in EdgeQL. So we can pop open Infinity War. We see our kind of annotated format here, see all of its properties up top, and then just continue diving deeper and deeper into the actors. We've got Anthony Mackie here. We can see his filmography and all the MCU movies that he's been in. And it's just a really delightful experience to kind of surf through your database like this. Of course, if you would rather go sideways instead of down, you can just hit View in Table. And now we can see the entire cast here of, was it Infinity War? And then as a shorthand for that as well, if we just want to see all of the movies that Anthony Mackie has been in, we can just tap on filmography again, and then that'll open up that new table here. This brings up another interesting point, which is that a person's filmography can consist of both movies and TV shows. So this is actually a table of content, not of movies. And that's why we have these indicators up here. So we can see the properties and links that are defined on show specifically, and then the ones that are defined on movie specifically, the two types that extend content. In terms of getting a little more fancy here, let's go back to content, and we can very easily drop into this filtering interface where we can do things like, say, we can provide an arbitrary EdgeQL filter actually. So let's just do title, I like Iron Man. And then that's going to be a case insensitive pattern match. So we can apply that filter. Let's try this on movie. Like last time, the universe will conspire against me and try to ruin my live demo. Let's go ahead and give that a shot. I put a semicolon, that's my problem. So as you can see, we're now fetching all the Iron Man movies there. If we want to briefly disable that filter, we can do so by just hitting the disable, reapply it, and then clear that entirely. And then another power user feature here, if you want to go into your test database, make some tweaks to the actual data that's in there, and see how that affects your application logic. Very easy to do. Double tap on any editable field, anything that's not read-only, and we can go ahead and update a title, hit the arrow to kind of stage that change. We have these gold indicators that kind of tell us, what has been edited, and we kind of store a list of, I guess, pending changes here. We can change release years if we wanted to. We can, keep navigating to other tables and keep on editing fields in, across several different tabular views. And then at the end of all this, we can do review changes. It shows us the exact EdgeQL that's going to get executed. And then fun thing is when we actually commit those changes, all of them get applied in a single query using free objects, which are one of the coolest features of EdgeQL. If you haven't played with them, I definitely encourage you to look into them, and they'll be making another appearance here during Sully's talk in just a second. I think that's the gist of EdgeDB UI. This is just the beginning for our plans for it. For starters, we are going to be working on some visualizations of query planning, query optimization plans, which we're excited about, and make it a little easier to do filters in the tabular view, things like that. So we're going to be cranking away on this, and absolutely, if you have any feature requests, then hit us up in the Discord chat or in the open an issue on EdgeDB repo. We're excited to see where it goes. That's EdgeDB UI. I'm going to now hand it off to our head compiler engineer Sully to give you guys a quick overview of the new group statement. So stop sharing, and then Sully, when you're ready, take it away.
All right. One second. One moment, I'm having a brief technical difficulty. Sorry, Zoom was not wanting to believe that I had the slides window up. All right. Hi, so I'm Michael Sullivan, and I'm going to be talking about our new group statement. This will be a pretty quick talk because we've built something that is, I think, deceptively simple. So first, why do we need a group statement? And the answer to that is aggregating data in queries is an important tool. It's an important tool, especially for when doing analytic style queries. And since analytic style queries aren't our #1 target use case, we felt okay, if not amazing, about not having it in 1.0. But we want to be able to support that sort of thing. And it's useful in other cases too. So we're really happy to be bringing it to you in 2.0. So let's step back for a second and talk a little bit about what SQL offers for grouping. It has a group statement that is you can add to a select, or a group clause you can add to a select. Like everything in SQL, the output must be flat. A SQL query returns essentially a list of tuples, a list of rows. The things that you can output from a group statement, you can output either the grouping columns or an aggregate of the things being grouped on. And this is very limiting. It makes sense in the SQL context because the only things you can output are these flat rows, but it really is quite limiting and isn't the sort of way we do things in EdgeQL. So we need a fresh design. And the core to that fresh design is, I'm not going to go into it, but one of the we talk about how EdgeDB is the first graph relational database. And one of the key tenets of graph relational databases is that attributes have a cardinality, which is to say that attributes on an object could be just one thing, or they could be a set of things. Objects can contain sets as elements. And so how do we leverage that in our group by? Well, to start off with, the key thing, right, is that objects can contain nested data. And one way that can happen is with free objects. So one of the core features of EdgeQL is that when you select objects, you can put a shape on the object to say how to extract the data, which data you want to extract, and even to write computed fields that do some modification of the data and output that. Free objects are just like a shape applied to an object, except that you aren't applying it to an object. You're just building up the data on an otherwise empty object. So here we have a really basic example where we're building up a free object with two fields called old and num movies. Old is a computed property where we select all of the movies released in 2008. And the key thing to notice about this is that it's a property on one of these free objects. It holds objects of its own, here movies that we can see the title coming out of, and it can hold multiple ones. And this coexists with a num movies field that's just a singleton, that's one number. And once we have free objects as a thing users can create, we start to wonder, can we use them in any of the other features we want to provide, since it's a really useful way to output data. And it turns out that we've made this the core abstraction of our group statement, which we're going to dive into now. So here's just the most basic group you can execute probably, which is we're going to group our movie. We're going to group it by the release year field, and we want the title output. So we can see on the right that we get a set of free objects back, and each free object contains one of the groups. And so each object contains three fields. One is the key, which has all of the keys that it's been grouped by. Here it's just release year, so we can see in the first one it's 2017, the second one is 2013. There's an elements field, which has all of the objects that were in that group. So here, the movies from each of those years. And we have a grouping field that says which grouping keys were used to produce that group. Right now, it's just that one key that we're always using, but we'll come back to that. So in that previous example, we grouped just by one of the fields on one of the fields, release year, because that is grouping on a field is probably the most basic use case, and you'll use it a lot. But we also want to be able to group on computed information. So here we use a using statement to declare a variable cast count, where we, for each movie, compute the number of actors in it, and then we group by that. So here we can see that we have all our movies with one actor, which is Ant-Man and Iron Man, which I suspect reflects more of a limitation of our example data set than any ground truth. But nevertheless, in addition to grouping by fields and declared variables, we can also group by tuples, by a collection of things. So here we're grouping by both cast count and release year. And we can see that in the key, it has both of these fields, cast count and release year. And we can see that Iron Man was the only movie with one actor in 2008, which again, data set issues, but we can see we're grouping by both of them. In addition to grouping by a tuple, we can also compute multiple groups in one group statement. So here we ask to group by cast count and release year, but we're doing it separately. So you can see in the data on the right that the first group comes from grouping by cast count. And so in the key, it has a cast count value, but its release year is empty. And in the grouping field, it says cast count, but doesn't have release year. And in the second one, it's reversed. There's a release year in the key, and the grouping is release year and not cast count. in addition to being able to explicitly specify multiple groups like this, we also support some of the same feature SQL has for supporting groups, like cube, where you can give a list of groups and it will compute by all the elements of the power set of that, and rollup, which will compute all of the prefixes of a list of grouping keys. So all of these examples so far have just been calling group and displaying the output. But like everything in EdgeDQL, we want it to be composable. We want it to be easy to work with other features and to do computation. And if you couldn't actually do aggregating computation on the group, it wouldn't be very useful. So here is an example of computing the number of movies made in each year in our data set, which is we group movies by release year, and then we get those shapes back, and we can apply another shape to adjust what data we're outputting. So here we grab the year out directly from the key, and we compute the number of movies just by doing a simple count of the elements. And then we can sort by the year after it. And you can see we've got a nice output on the right. This would be pretty easy to do in SQL, but there's also a lot more you can do that would be much, much trickier. So here we want to find the movie from each release year that has the smallest cast. And so we do that by grouping by release year. And then we go do some computation. And the computation we do is for each of these groups, we select out of the elements, we order it by the number of actors, and then we limit one to take just the smallest. This would be a hassle to do in SQL, but it's an absolute breeze with the EdgeQL group. So that's sort of all we're going to talk about it, but that's most of it. So I encourage you all to go try to play around with it, and I hope you have as much fun using it as I had implementing it. And with that, I'm going to talk very briefly about the implementation of our group statement. So just as quick background, EdgeDB is backed by Postgres. And so we use PostgreSQL as our backend database. And so EdgeQL is compiled to SQL. We take our EdgeQL queries and compile it to SQL. So our compilation of group works in a couple steps. The first is that we actually, in order to separate the concern of producing the shapes from the concern of computing the grouping, we desugar our group to an internal lower level group statement that we don't expose to the user, but that our implementation works in terms of. So when we group by release year, we use this lower level group to do the grouping, and then we explicitly build up the shape while iterating over all those groups. And as a fun internal fact, the design we use for our internal lower level group was one of our first sketch designs for EdgeQL group. And it was a fine design, but it lacked some of the elegance of directly using free shapes, which were free objects, which were a surprisingly late addition to EdgeQL. And then once we have this internal low-level group, we need to compile that. And unsurprisingly, we use SQL group to implement our grouping. But there's a few subtleties. One is for efficiency purposes, when we're computing an aggregate, like count or sum, for example, in the number of movies from each year example, we try to lift those aggregates up and put them directly in the group statement so that they're computed in a idiomatic SQL way. When you're doing more complex things, like trying to get the smallest cast for each year, we have to do something more involved, which is we collect all the objects in each group with an array egg. And then when we access the groups later, we unpack the array so we can get at the objects. And this is a technique that we have to use in a number of places. So that's all I really have to say now about the implementation. I, again, really hope you all enjoy using our group statement. And I think up next is our CTO, Elvis, to talk about our access policies.
All right. So quick intro here for Elvis, or some brief programming reminders before we jump into access policies, is that for people who got here late, the main chat room or comment section for this is actually in our Discord. There's a link in the description. It's the #V2 channel. There's also some additional discussion happening over on Hacker News for those who are so inclined. But thank you, Sully. There's no one better to talk about group, and if I may say, you absolutely nailed it. Now over to Elvis, our CTO, talk about access policies and how to use them for object level security. Take it away.
Hello, everybody. Thank you for joining us. I'm Elvis, co-founder and CTO of EdgeDB, and this is really a very, very quick introduction to a great new feature we've added to EdgeDB 2.0, which is object level access control. But before we really start showcasing the feature, I'd like to talk briefly about why we thought it's necessary to have object level access control in your database directly. And so many applications, really a majority of applications, especially web applications, are multi-user, which means multiple users are accessing data at the same time. And also, it's often the case that those users have varying levels of access to that data. So think like you have regular users, administrators, like various different kinds of managers, especially if it's a complicated app with different kinds of data. And really, improper access to data or data leaks are a major hassle. And it's like the ramifications of data leaks are very big and can sometimes destroy the company. And so the traditional way of enforcing access rules at the application level is to essentially just code them directly with a bunch of conditions and filters everywhere, which is both tedious and error prone because it's really easy to sometimes forget to insert a certain filter, or maybe a schema changed and then somebody forgot to insert a specific access rule somewhere, and then you have improper access control. And so let's take a quick example of an e-commerce platform schema. So imagine like there's something like Shopify, where there are stores and there are store orders where customers make orders, which is like a really simple type where you have a customer, a store, and say a total cost of the items in that order. We also have a user, and we have a store, which has a manager that a special kind of user that manages that store, which is essentially in Shopify that will be your store owner. And so this is an example of a really simple function that basically returns all orders made by the currently logged in user. And it's really simple. It's like you just select a user. It's a very simple SQL expression. You select all orders and you filter by customer ID, and you get your customer ID from, say, a cookie after they logged in. Now, let's see how the same function might look for a store manager. It's a similar query, but instead of filtering by the customer, you now need to filter by the store manager ID. And you get the user ID from the same cookie, but we see that this is a although very similar query, it's still different and you still need to code it. And basically, if you think about it, the more data you have and the more kinds of users you have, this sort of field of combinations of those data and different accesses grows and essentially forms a cross product of cases that you need to handle everywhere. And the more API handlers you have, the more logic you need to insert in your app, which of course brings me back to the subject of this talk. EdgeDB allows specifying access rules per type directly in your schema with a new access policy declaration. And an access policy is essentially defining on a policy on every action that you can make with data, like select, insert, update, or delete. And you can specify an expression that would either allow the object to be selected or updated, or it would be denied. So we have both allow and deny rules, and I'll explain a little bit later how those are different. Now, here's an example of such an access policy. Essentially, this is the same filter that we saw earlier in that example function, which filters by the customer. Oh, there's a bug in that expression. It should say customer.id. And there's another cool feature there, which says global current user. We'll talk about globals a little bit later, but this is another addition in EdgeDB 2.0 that kind of drives the whole mechanism of access policies, is that you can now define global variables and set them separately from your queries. So kind of a way to establish a context to your queries. And you can use globals anywhere in your schema or your queries. And this is how you define a global. And so basically, going back to our getOrders function, this is how it looked before we added an access policy. But now that we have access policy on the store order, we can simplify it down to basically essentially just this, because the access policy injects that filters into this query, and in fact, every query that touches the store order type automatically. So you don't need to worry about this anymore. You don't need to do this in every function that selects a store order and filter by the current user. And this is basically a quick example of how this actually works in actual code. How do you pass that current user to those queries now? Because we actually still need to have that user ID somewhere. And so this is an example of that API. And in practice, you do this somewhere in request processing middleware. You take that cookie and you configure your database client with, here's my current user, and you can have an arbitrary number of such variables if your application needs those. Okay, so what about that other example of a store manager variant of order fetching function? It's really simple. We just add another rule that also allows store managers to access store orders if they are the manager of that store. And allow rules are additive. In other words, an object is visible in a query if at least one allow rule matches. So you can sort of stack those rules this way. As I mentioned earlier, access control rules or access policies specify which database action they apply to. It's either select, insert, update, or delete. And where select and delete rules simply skip objects that are excluded by the access rules, so if they just become invisible to your queries, insert and update, or essentially update write rules, because there are two kinds of update rules, update read and update write. They actually raise an error if violated, if that condition that you specify in that policy is not true. And this is a really powerful mechanism that essentially opens the door to a much more advanced mutation control than was previously possible with constraints in EdgeDB schemas, because constraints are fairly limited in what they can do. And this shows an example of how you can add a rule that enforces the limit on a maximum number of deficit items one can order. Like think of a GPU that there's like one per order. So you can set that limit on your item and then have a policy such that it essentially rejects all orders where the number of those items is greater than the amount allowed. And this is at the schema level, so this is guaranteed to be enforced. You cannot write an insert statement that would violate this rule. So it's very reliable. And of course, it's just a glimpse of what access policy rules can enable. And this is another cool example where the generality of this query rewrite is such that you can enable interesting patterns like temporal data. And this is an abstract type temporal here. And like everything in EdgeDB schema, you can inherit declarations from a supertype. So all subtypes that inherit from temporal will essentially inherit this access policy. And so basically what it does, it hides objects that are outside of the validity period that is configured for those objects. And this example actually shows another cool thing that we've added in 2.0, which is range types. It's something that exists in Postgres, but EdgeDB didn't expose it in 1.0, and now we do, and with some interesting applications as well. So this is it for the quick sneak peek at the access policy, the new feature in 2.0. You can learn more about it and other new features on edgedb.com/docs, and we'll have some cool guides posted soon that use access policies. Thank you for listening, and with that, back to you, Yury.
All right, thanks, Elvis. Another quick thing to point out is that we have some examples that make use of access policies in our EdgeDB-examples repo, which you can find on GitHub, or just Google EdgeDB examples and it'll be easy to find. And we have examples for both Python using Flask, and then with JavaScript using Next.js. So definitely take a look at those. I can say from experience building those that having all of your authentication, or rather authorization logic, baked into your schema like that is a fantastic developer experience. All right, thank you. Yury, take us out.
Thanks, Colin. Well, this is it. Thank you so much for being with us today. This release shaped up pretty well. We implemented everything we planned for, and then some more. EdgeDB 2.0 is here, and it's ready for you. Start using it and tell us how it goes. What's next? Well, next is EdgeDB Cloud and EdgeDB 3.0, obviously. I can't share much about Cloud right now, except that we are working hard to launch it as soon as possible. It takes some time because we want to make it great. One command provisioning, great UI, seamless DX. It's a big platform, and it will be the foundation of our business, so we take it extremely seriously. If you want to be among the very first few ones to get access to it, please join our Cloud waitlist. The link is in the description. All in all, we plan to launch a private demo in a couple of months, so stay tuned. As for EdgeDB 3.0, we plan to release it in about 6 months. At this point, we'll have a few new features in mind. One of the most requested features is the explain command. Similar to Postgres explain, you will be able to see how your query would be run exactly. We also plan to make the output of it readable and actionable. We'll likely have a great visualization of query plans in our new UI. Next, we want to allow user-definable error types, or exceptions. The necessary groundwork for that to happen will also enable things like deprecation warnings, better logging, better interactive prompts in REPL. You will be able to define custom error types in your schema and raise them from your SQL queries, improving troubleshooting in complex systems. Finally, the built-in error types would become fully introspectable, greatly simplifying implementation of client libraries. We also want to add support for so many other features, like full-text search, role-based access control, add splats to SQL shapes, implement multi-ranges, further improve GraphQL support, continue to prepare EdgeDB for backendless development, and a whole bunch more. I can only promise that we're in for an exciting ride. With all that said, it's time to wrap up this event. Thank you for joining us. It truly means a lot. To stay in touch, please join our Discord or follow us on Twitter. And lastly, please spread the word about EdgeDB. I believe it's time for it to hit the mainstream. Thank you so much, guys. I hope to see you soon again. Goodbye, and all the best.